Alright guys, today we're going to be talking about graphing linear inequalities. By the end of this lesson, you should be able to graph the solutions to a linear inequality in two variables as a half plane, and then analyze the graphs of linear inequalities to determine the solution sets. Alright, so it says write the notes down from the video lecture. I'm on slide 2. I suggest that you use the text feature in order to type. So let's go ahead and type some notes out. So our main idea is that a linear inequality is similar to a linear equation but uses an inequality symbol. And then the solution to a linear inequality is that all of the ordered pairs that make the inequality true would be a solution to a linear inequality. Alright, so if we have this example, it says determine which ordered pairs are solutions to the linear inequality below. I still suggest they use the text feature. Remember, the 2 is going to be our x, and then the 5 is going to be our y. So what we want to do is we want to substitute in the x value into this equation right here, and then we want to substitute in our y value into this equation right here to determine if we're having a solution or not. So I have 2 times 2 minus 3 times my y, which is 5, is less than 15. I can drag this over here. And then I want to simplify. So 2 times 2, that's going to be 4. And I'm going to change this color to, let's make it purple. Okay, so I have 4. I need to make my box bigger so I can type. 4 is 4 minus 15, 3 times 5 is 15, is less than 15. And then I want to simplify, so 4 minus 15, that's going to equal, so I have negative 11 is less than 15, and that's true, so I'm going to say yes, this is a solution to the linear inequality. As long as this is true, then it is. Let's check out this next solution. So I have negative 1 comma negative 7, and again I'm going to substitute it into this inequality right here. So I have 2 times my x, which is now negative 1, minus 3 times my y, which is now negative 7, is less than 15. So 2 times negative 1, that's negative 2. And then I have negative 3 times negative 7, that's going to become, let me bring that out a little bit, positive 21 is all less than 15. And then when I go to simplify that, I get 21 minus 2, which is going to be 19. So I get 19 is less than 15, and that's not true. So no, this is not a solution to the inequality. All right, now I'm going to try this next ordered pair. So I have 2 times 3 minus 3 times y, which is negative 4, is less than 15. Okay, and now I'm going to go ahead and simplify by multiplying. So 2 times 3 is 6, and then negative 3 times negative 4 is going to be positive 12. This is a plus 12. Is all less than 15. Let's see if this is true. Alright, so 6 plus 12 is going to be 18, so I get 18 is less than 15, and again that's not true, so I'm going to write no, it's not a solution. And now finally we have this last ordered pair, 0, 0. Let's see if that's a solution. So I'm going to get 2 times x, which is 0, minus 3 times 0, which is going to be 0, is less than 15. You can drag out the box if you need more room. There we go. Alright, so I'm going to get, just showing my work here. So 0 minus 0 is less than 15, or 0 is less than 15. So 0 is less than 15, so yes, 0, 0 is going to be a solution to my linear inequality. Alright, let's go to slide 3. So we have a few more notes here. So when we're graphing linear inequalities, we have a few steps. Graphing linear inequalities is a way to show all the ordered pairs that are solutions. Here's the steps to graph. Step 1, put the inequality in slope-intercept form. So I'm going to use my text tool here, and I'm going to write slope, intercept, form. And then it says, be sure to flip the inequality symbol if you multiply or divide by a negative number. Don't forget that. And then when we're graphing the lines, we're going to use a solid line. Put that up a little bit. And I'm using my drawing tool here. If I have a greater than or equal to symbol, or a less than and equal to symbol, and then we're going to use a dotted line if we have if I have the less than or the greater than symbol. Alright, so we want to shade above the line for greater than or greater than and equal to symbol, and we want to shade below the line for the less than or the less than or equal to symbol. Go ahead and pause the video if you need to write your notes if I'm going too fast. Alright guys, I'm on slide 4. Let's go ahead and look at this example. So I have 2x minus 3y is less than 15, and I want to graph this. Let's go ahead and first put it in slope-intercept form. So I need to move the 2x the other side, and I'm going to pretend I have a positive 2x here. So I'm going to do the opposite of addition, and I'm going to subtract 2x from both sides. Now when I do that, my 2x's are going to cancel, and then I'm going to get negative 3y is less than negative 2x. I can't combine this because it's not a like term, so negative 2x plus 15, that's a positive 15, so it's plus 15. Alright, now I just need to go ahead and divide both sides by my coefficient. So I'm going to divide both sides by negative 3y, and you guys can also draw this on your Desmos as well. So I'm going to divide both sides by negative 3. So when I divided both sides by negative 3, if you multiply or divide by a negative, you have to flip the inequality symbol. So notice that I go from y is less than x to now y is greater than x. And now my slope is going to be negative 2 divided by negative 3 becomes positive 2/3. So my slope is going to be 2/3. And feel free to pause the video if you need to. And then 15 divided by negative 3 is going to become negative 5, so my y-intercept is negative 5. So when I go to graph this, I'm going to put my first point at negative 5 on the y-axis, so that's going to be negative 1, negative 2, negative 3, negative 4, negative 5, all the way down here. That's my y-intercept. And then from my y-intercept, I'm going to use my slope to rise up 2 and to the right 3. 1, 2, 3, and put a dot there. And then rise up 2 and then to the right 3, so that's about there. So I have these 3 points on my graph. And what I want to use is the straight line tool, but Because y is greater than 2/3 x minus 5, I'm going to have a dotted line because it's not equal to, and then because y is greater, I'm going to shade above. So I'm going to have my dashed line looking like this. Okay, and now I want to shade above. So with my drawing tool, I'll make this like green. I'm going to shade above the dotted line. And that's how I would graph the inequality. Feel free to pause the video in order to draw all of this on your Desmos activity. Alright guys, let's look at slide number 5. So slide number 5 is an introduction. So we know that if we have y equals 3/2 x plus 3, my y-intercept would be 3, and then my slope would be up 3 to the right 2, and I would just draw a straight line. But with a linear inequality, I also have to shade, and I have to look at the inequality symbol and say, okay, it's equal to, so that means I'm going to have a straight line, and then y is less than, so I'm going to shade below. Linear equations have one solution for each x value. All the solutions to the equation make up the line that you draw for the graph. Linear inequalities are different because, similar to number line inequalities, the solution set makes up an entire region of the coordinate plane. Today we will explore how to graph and write the equation of a linear inequality. We will also identify different solutions to the inequality. Alright, so let's try show your work on this journal. Write the inequality -4x plus 2y is less than 10 in slope-intercept form. So you can either use the typing feature or the drawing feature. I'm going to use the typing feature. So I'm going to first write the equation -4x plus 2y is less than 10. And then in order to be in slope-intercept form, remember that I need to have it as y equals mx plus b. So I want my x and my y-intercept, or my slope and my y-intercept on one side and my y value on the other side. This is, remember, slope-intercept form. Okay. So back to here, what I want to do is I want to do the opposite of subtraction. So I'm going to add 4x on both sides. So I just add 4x to both sides. And when I do that, my x's are going to cancel on this side, and the 2y is going to come on down. So I'll get 2y is less than 4x plus 10. But I'm not done yet. I still have to divide both sides by my coefficient to get the y by itself. So I'm going to divide both sides by 2. So I divide both sides by 2, and then my 2's will cancel. And then I'll get 4 divided by 2, which is 2, and 10 divided by 2, which is 5. So when I rewrite this into slope-intercept form, I'm going to get y is less than 2x plus 5. Alright, feel free to pause the video if you need to. So the next slide, slide 7, wants us to rewrite the equation in slope-intercept form, which we've already done. So now we just have to identify the slope and y-intercept. My slope is 2/1 and my y-intercept is 5. So I need to find my y-intercept, which is right here, and I'll put a dot. And then from my y-intercept, I want to go up 2 and then to the right 5. So I'm going to go over 1, 2, 3, 4, 5, and put a dot. And I can do the same thing again, go up 2 and to the right 5, 1, 2, 3, 4, 5, and put a dot. And now I just have to graph. So if I look at my inequality symbol, this symbol means below and dotted. I could also just look at my notes to remember that if you wanted to go back a few slides. So I'm going to go ahead and use this line tool to draw a dotted line across my graph, and then I want to make sure that I shade below. And if it's not perfectly straight, that's okay. And then we just shade below, and we're done. I want you guys to go ahead and do slides number 8, 9, and 10. Make sure you check out the part 2 video for what you guys are doing on Wednesday.